Okay, let's dive right in. We're gonna talk in this session about packaging and uh, importing packages and modules and the Python package ecosystem. This is one of the reasons why Python is so popular because the ecosystem is huge. Whatever you want to do, if you are thinking of writing a more complicated part of your code, it's always worth looking whether somebody else has done it already and published it open source. And then you can import it and access all of the code very, very quickly and easily. This is the idea behind it. Don't, if you do something complicated, you publish it, let other people work with the same code. This is why computer programming has become so efficient. The open source world is really one of the crucial aspects of software engineering that has made it very, very successful. So the way this works is you want to do something complicated like analyzing correlations, for example. So you'd have to write some pretty complex code, many, many lines of code to get an answer. But with a library like Pandas, for example, you import that code already into your program, and then all you have to do is you access this object, and the object does everything under the hood, and you just access a function or a method in the object, and then this is all done. So you don't need to worry about the fine details of the code. And this makes it possible to do really complicated things in Python very quickly. For example, visualizations, writing graphs, making beautiful figures and things like that, and analyzing complicated statistics. And this is where we're going to get started today. So to explain you what these packages or these objects actually do, I'm using here a metaphor that I think Steve Jobs came up with initially, and I think it's quite, if you once you start working at this, it'll make sense. I hope it'll make sense right away. So imagine you fly to Japan and you only have one shirt, and when you're on the plane, somebody spills coffee over your shirt. So you get off the plane, and then you have two choices. Either you want to find a laundry, so you have to go and find a map, navigate the underground system in Tokyo, which is complicated to say the least, and then find a laundry, start, look for the instructions, all of this in Japanese. You'll get really lost. You start sweating. It's gonna be very, very hard, and wait for hours to get it washed. So this is not the way you would choose to do it. Much easier is you hand your shirt over on a reception, and they will take care of everything that has been described here. And then in the end, you get your clean shirt back. So this is the do-it-yourself approach. This is the object-oriented approach, where you are dealing with code that other people have written. You have to just interact with this code via a reception kind of thing. These receptions in code are called APIs, or application programming interfaces. This is where the applications that other people wrote can interact with you, and you can tell them what to do. Sounds a bit complicated, but it really isn't that difficult. What you have to the way to visualize is that um, um, these kind of complicated scripts and algorithms have been packaged into unified objects, and then you can access these functions via just simple calls for do something, and then you don't have to worry what's happening under the hood. And we will get to that right away. So at the moment it's in theory, but in practice this looks quite easy, and it makes things possible for that would be very, very hard for us as beginning coders to do. So there's two types of Python packages. One come built in the standard library. So these are, at the moment, we've just dealt with the core syntax. But within Python, people have already written functions for easy usage that, for example, to interact with the operating system, to find paths, to do more complicated math. One of the most useful ones is to generate random things, which is quite complicated in programming. So these ones, they come with the core Python, and you just import them. Uh, Then there are outside packages that other people have written and published open source and maintain as open source packages. There is a repository for this type of code. It's called the PyPI site, and there's hundreds of thousands of these packages. There's some really famous ones like Pandas, NumPy, Matplotlib, BioPython, SciPy, Seaborn. So these will be the ones that we'll cover in the next lectures. These are incredibly powerful tools that really supercharge your capacity to be productive with Python very quickly. And again, for this, when you write the code on your own computer, you have to actually get them from the internet. You have to download them. There are very good tools like UV, for example, and we'll cover that in the resources to install them. But because we're working Google Colab has pre-installed most of the standard packages, so you don't need to do it. You can do the install within the cell, but and we cover that later. But today Pandas is pre-installed, so you don't have to worry about it. What you do have, you have to import it into the notebook, so you again have to write this import statement. And with Pandas, we say import Pandas as PD, so we don't have to always write out Pandas. We just have a short version PD, but we'll cover that later. So for local development, you have to import things. You have to be careful what you have. So this is a little bit more complex. Google Colab, easy. You don't have to worry. Most things are pre-installed. All you have to do is import the packages you want to work with in a particular cell, and this will work fine.